For the frequency response section of the lab, you'll refer to the previous videos for the input displacement of the single cart system to determine the input displacement that your motor is running at. You will connect the string from the motor, again threading it through both of those holes, onto the spring, which is connected to the first cart of the system, which again is connected via spring to the second cart of the system, which then is connected to the end via another spring. From the capstone VI again, with the carts selected and connected to your VI, as well as appropriate sampling settings being made again, you'll start sampling and start up your power supply, which will then drive your motor. Now, we've selected a random voltage just to start with. In the actual lab, you will increment through voltages from 2 to 14 volts as you did before to accurately map out your Bode plot. Notice the motor is spinning, which is inducing motion in the carts. Now you can see that the blue cart is barely moving, indicating that the node is probably right above that cart, while the red cart is in fact oscillating back and forth. The motions of each cart may be seen in the VI, and you'll allow them both to come to steady state before you cease taking data. We can notice that the red cart is pretty much in steady state, and the blue cart is very much governed at this point by nonlinear dynamics. So you would usually let this go a little bit longer, but for the purposes of the demo, this would be a good place to stop the acquisition of data and then export your data as such. Again, you'll make sure to measure the RPM the motor is running at with the tachometer, just as was done in lab 4, the previous lab. Again, that's getting a reading in RPM.